Okay, in this video lesson, we're going to start off with our new unit on solution chemistry. So let's jump into it. The first thing we need to know when we're talking about solution chemistry is a reminder that the word solution and the word homogeneous mixture mean the same thing. Okay, so if you're creating a solution between two different substances or a physical mixture between two substances, and you evenly distribute those particles throughout the substance, make a homogeneous mixture, we then create solutions, okay? Now, solutions typically in the chemistry world are of liquid nature, okay? But keep in mind, you can have gaseous solutions, you can have solutions that have been solidified, like the alloys we've talked about previously, like air is a solution of different particles in a gaseous form. So we do have the ability to have solutions that are not liquid, but for the purpose of this unit, we are primarily going to talk about solutions where you have a solid or a gaseous solute dissolving into a liquid, which is most likely going to be water for us, okay? So let's go through some terminology that we need. First of all, what is a solvent, all right? So when we talk about solvents, they're the particles within the solution that cause the separation to happen. So they force the separation of the solute particles and they dissolve them, okay? Water sometimes is often known as that universal solvent. So in our unit in particular, unless we say otherwise, we're going to assume our solvent is water. We will talk about other solvents, non-polar solvents, but water is probably our best solvent that we have due to its high polarity and intermolecular forces. In terms of like the amounts, usually your solvent is going to be your greater amount of the two things. Now the solute that we use, that's going to be the substance that does get broken apart and then gets dissolved by the solvent, all right? It can come from a solid, a liquid, or a gas. It does not matter what the solute was. And usually we see that in the lesser amount of the solution, okay? So looking over at this picture, our orange spheres evenly distributed through this would be considered our solute particles, and our blue spheres, which are the majority of them, probably water, would be considered our solvent particles in this, okay? So be very comfortable, hopefully, with these two terms, because we're going to talk about the solute versus the solvent a lot in this unit. Now, the next thing we want to talk about is how do those solutes dissolve, okay? So what's the actual process of dissolving going on, all right? Things we need to remember, or take a look at, I should say, is that there's actually the dissolving process first, step one, and then step two is a hydration process, okay? So it's always kind of like a two-step process. The dissolving process is all about separation. So it's pulling things apart to get them into solution. If that was the only thing that happened, they would be unstable and then they would fall back into solid or gas form again. So the second part, this hydration part, where the water molecules in particular surround these particles that have been separated and kind of stabilize them, that's kind of key because we first pull everything apart and then we stabilize them by having water surround it. Now, for ionic compounds, once they surround, that creates that ion-dipole interaction that we talked about previously. So you have a fairly strong attraction between the ions for ionic compounds dissolved in solutions and water for that ion-dipole interaction. If you have polar molecules, it's just a dipole-dipole interaction. But that interaction or that IMF holding everything on is what stabilizes it, okay? We really should spend some time talking about the difference between how molecules dissolve versus ionic compounds. And we have mentioned this earlier in the year, but now it's kind of time to actually get into our notes, okay? So for molecules, we say they undergo a solvation process, okay? Not salvation, it's a whole different thing, solvation. In solvation, the molecules are going to stay in their groups, okay? So this image up here kind of shows that, where if this was a glucose molecule, we have a whole bunch of glucose attached to themselves, held together by the dipole-dipole interactions here. And then now you see these big clusters of glucose that have been separated from the bigger chunk. These have undergone solvation, okay? And then hydration as the water molecules surround them and stabilize them, okay? Notice for molecules that the groupings, okay, stay together on those. Now, for ionic compounds, that's different. For ionic compounds, when they dissolve, they don't stay in their groups. They don't stay as NaCl. They split into separate ions, okay? So you have your Na plus and then your Cl minus. This little video is going to show us that in a little bit more detail.
When an ionic substance, such as sodium chloride, is placed in water, water molecules interact with the ions on the surface. If the salt is soluble, the attractive interactions with water molecules overcome the ionic attractions within the lattice. the solvated ions move off the surface and become separated in solution. Notice that water molecules cluster about the anions with the hydrogens directed toward the negatively charged ion. On the other hand, water molecules interact with the positively charged cations through the lone pairs of electrons on the oxygens.
Okay, so we see here that we have two separate ions. Notice how there's water between them, okay? Now, the water surrounding them, that's that hydration step where they stabilize them. Again, we'd have that ion to dipole interaction. And they're talking about, well, which way would the dipole face? Well, because of the partial positive and partial negative, they actually arrange themselves according to that plus-minus attraction, where the negative oxygen would arrange itself facing the positive ion, and the positive hydrogen would arrange itself facing the negative ion. But they are separate, and they are stabilized by the water around them, which is very different than the molecule where these individual atoms here don't split apart inside there. This is going to cause a pretty distinct difference into what we can do with ionic compounds dissolved in water versus having molecules dissolved in water, okay? Now, that brings us to our next topic here, which is about like dissolves like. I'm going to stop the video here and do another segment with this. Thank you.